The purpose of this short video, hopefully it will be short, is to give a quick overview of composite functions or composition of functions, typically known as the fog of x and gof of x. F composition g of x, which is equals to f of g of x. In other words, we're going to evaluate the function f with g of x as input. Every time we talk about composite functions, we need to identify which function is quote unquote the inside function, which function is quote unquote outside function or the dominant function. So in this case, when we are doing for fog, g goes inside f, not multiplying, evaluating f using g of x as input. Likewise, when we do gof of x or g composition f of x, which is equals to g of f of x, now g becomes the outside function, f becomes the inside. So we're going to input f of x inside g of x, which is again the outside function. Let's go ahead and take a quick, let's do a couple of examples. The first one is f of x equals 3x minus 5, g of x equals negative 7x plus 1. F of x, for example, is the input. Once we get the input, we multiply 3 times the input minus 5. Likewise, g of x tells me whenever the input comes in, multiply by negative 7 and add 1. Therefore, if we are going to find the fog of x, which is defined as f of g of x, we are simply looking for f, which is my outside function, is 3 times input minus 5, namely 3 times input minus 5. Now we're going to evaluate f with g of x as input. So now we input here negative 7x plus 1. There should be a 7. So now we just simply do simple algebra. 3 times negative 7, of course, is negative 21x. 3 times 1, that will be plus 3 minus 5. And now we can just combine any like terms. So negative 21x minus 2, and we are done. Don't do anything else. This is it. Now let's go ahead and find g of f of x. Oops. The definition is g of f of x. In other words, now g becomes the outside, quote unquote, the dominant function. We're going to input f inside g. My g function is negative 7 times input plus 1. Negative 7 times input plus 1. But now with the gof, what is the input? Of course, the input is, where am I? F of x. So now we need to input 3x minus 5 here where x is. It will be 3x minus 5. And that's the actual composition. Now we just have to do simple algebra. Negative 21x plus 35 plus 1. That would be negative 21x plus 36, and we are done. Yeah, that would be a very basic composite function where the two functions are linear. Notice that the domain of f of x is all real numbers. This is a linear function. The domain of g of x is also a linear function. Therefore, the domain is all real numbers. And of course, my two resulting functions are also linear. The domain of real numbers, so we are safe. Let's try another example. What about now as a second example, f of x equals 2x squared minus 5x. G of x is x plus 1. When we look for fog, namely f of g of x, in this case, f is my outside function, which is 2 times the input square minus 5 times the input x. And once again, my input will be g of x. So I need to input x plus 1 instead of the x. So we replace x by x plus 1, x plus 1. And we just do the algebra, no big deal. Multiplication exponent, given that due to PEMDAS, of course, the exponent goes first, is going to be 2 times x squared plus 2x plus 1. When I fold x plus 1 times x plus 1, minus 5 times x plus 1. So now I have multiplied by 2 to x squared plus 4x plus 2 minus 5x minus 5. Now we just simply combine like terms. 2x squared, 4 minus 5 minus 1x, plus 2 minus 5, negative 3, and we are done. That's it, don't do anything else. Likewise, let's go ahead and find g of f of x, or g of f of x. And this one, g, is my outside function, the dominant function, which is x plus 1. So instead of x, we're going to punch in f of x, which is 2x squared minus 5x. Notice there is nothing much, actually, there's nothing much to do here. Just simply, I'm just going to rewrite it. That's it. There's nothing to do here. Once again, my f of x is a quadratic function, so the domain is of real numbers. G is a linear function, therefore, all real numbers as a domain. The resulting functions are quadratic functions, therefore, all real numbers. So we are safe. Before we do example number 3, let's talk a little bit about the domain of the composite function. The domain of the composite function, let's go ahead and assume that the domain will be given by all real numbers, except if there is an exception, these are where the 2 exceptions will come. One will be the section of the restriction due to the quote-unquote inside function, and the other restriction will be due to the final answer. I know this is not mathematically correct, this is not even grammatically correct, but hopefully you understand what I'm trying to say. So we are going to assume that the domain will be given for all real numbers, and then we'll look at the inside function. Is there anything that we need to be careful about the inside function? And then, is there any red flags due to the final answer? So let's look at 2 examples. So let's look at this example. F of x equals 1 over x plus 5, g of x 7 over x minus 3. Unlike the previous examples that the 2 functions were linear and or quadratic, these are rational. These are a ratio, a fraction. This is a rational function where my x, my independent variable, is part of the denominator. So we have to be careful because, as you know, we need to avoid 0 in the denominator. So for example, in f of x, we like every number except when x equals negative 5. Why? Because when x equals negative 5 plus 5 will be 0. 1 divided by 0, undefined. Similarly, in g of x is 7 over x minus 3. Of course, x cannot be 3, because when x equals 3, 3 minus 3 is 0, 7 over 0 will be undefined. Okay, so let's keep that in mind. Let's go ahead and find fog of x, which is given by f of g of x. Once again, sorry, I love to repeat, f will be the outside function, so we need to input 7 over x minus 3, where x is here. So the f of x is 1 over x plus 5. Well, now we need to do the actual composition. So instead of x, we're going to evaluate this function with 7 over x minus 3. Okay, so here this guy will be the inside function. So remember what I wrote before, the domain of f of 4 will be all real numbers except. So far the domain will be all real numbers except. We will have a couple of restrictions. One restriction is given by the inside function. Is there any number I need to avoid here? Of course, we need to avoid 3. Is there any other restrictions? We don't know yet. So far, the only restriction comes from the inside function. Inside function x cannot be 3. So far we assume the domain is all real numbers except 3. I don't know what else is here, so we'll find out. Now, once you do that, you get what we call a complex fraction. And as we learned previously, how do I simplify a complex fraction? The easiest way, one of the methods is to multiply by the LCD. This is over 1, 1 over 1. So my LCD, of course, is x minus 3. So we're going to multiply by x minus 3 everywhere. So let's see what type of mess did we make, other than the mess in my hand. So we have 1 times x minus 3, just simply x minus 3. In the denominator, x minus 3 over x minus 3, bye-bye, adios. So I have 7 plus. That is, distribute the 5. 5 times x, 5x. 5 times negative 3, negative 15. Let's clean this up a little bit. So it's x minus 3. 5x, 7 minus 15, 7 minus 15, negative 8. So that's my fog, that's my composition, that's my final answer. Now, is there any number I need to avoid here? Absolutely. Once again, this is a rational function. I must avoid 0 in the denominator. So of course, you can do it mentally, or we can do it on the side. So when 5x minus 8 equals 0, we may add 8. 5x equals 8, and we may divide by 5. So x equals 8 over 5. So in this case, my domain will be all real numbers except 8 over 5 and 3. And we are done. Okay, so we are just write it here. So therefore, the domain is all real numbers except 8 over 5, not over 3 over 5, 8 over 5 and 3. If we need to input this in interval notation, so remember, how do I write this in interval notation? It will be, of course, we have the real line from negative infinity to infinity. Let's just place 3 here. 8 over 5 is 1 point something. So that would be 8 over 3. So what's the answer? Either in set notation or from negative infinity to 8, negative infinity to 1/3. So again, the negative infinity to 8 over 3 union 8 over 3 to 3 union 3 to infinity. It got a little bit messy there, and of course the logo of ManiCam is in the way, but at this point I believe you know it will be from negative infinity to 8 over 3 union 8 over 3 to 3 union 3 to infinity. And of course I made a mess. I forgot to do the g of f, so I do apologize, I erased it. So I have no way to see the examples unless I stop the recording, finish it, and then I watch back. So I'll leave it up to you to do the g of f, of x. Hopefully you'll be able to follow it. Now f of x, let's try another example. What about if I have x over 2x minus 5? G of x will be 8 over, just do, I don't know, 7x plus 2. Okay, notice that this one has x in both the top and the bottom, so that will be interesting. So let's go ahead and find fog, f of g of x, which is f of g of x. It's going to be quite messy. We'll see what happens. So we have x over 2x minus 5. 2x minus 5. So let's go ahead and do the actual composition. This will be 8 over, I think there was a 7. 7x plus 2, and it will be 8 over 7x plus 2. Again, we have a complex fractions. However, I recommend to multiply, this is over 1, so I multiply just to keep it simple. This multiply 2 times 8, just to make our life simpler. So it will be 8 over 7x plus 2 over 2 times 8, that's 16 over 7x plus 2 minus 5. Again, how do I simplify a complex fraction? I just simply multiply by the LCD. This is over 1. My LCD is 7x plus 2. Just this 7x plus 2. Okay, so when I distribute this times that and this times that, let's see what we get. You continue here on the side. So I have 7x plus 2 or 7x plus 2 by, so it'll be 8. When I distribute the 7x plus 2 times the first term, numerator denominator cancels, so it will be 16 minus 5 times 7x plus 2. We continue here on the side. So this is 8 over 16 minus 35x minus 10, which is the same thing as, let me continue here on the side, 8 negative 35x, 16 minus 10 minus 6. And so this is my final answer for the FOG. That's what we're doing, f of g of x. And the only thing we need to do is to find the domain. Okay, so the domain would be, let's go ahead and assume that it will be all real numbers, except one exception will be from the inside function. So one number I need to avoid here, and the other restriction will be one number I need to avoid here. So what do I have? The first one would be 7x plus 2 equals 0, because it's in my denominator. I subtract 2, this 2, so I divide by 7, so x equals negative 2/7. Here, what's the other one? So this is the first number, negative 35x minus 6 equals 0. Negative 35x minus 6 equals 0. I add 6 and I divide by negative 35. So that's my second number. So what can we conclude? That my domain is given by what? All real numbers except negative 2/7 and negative 6 over 35. And we are done. We have our final answer and the domain. Let's go ahead and find the GOF. This time I'll do it with you, but I want for you to try it first and then we'll show it. Okay, so hopefully you're working on the G of f of x. If not, you should pause the video, then attempt it on your own, and then compare notes. Okay, so go ahead and pause the video if you want to, and then resume watching it in a few. So let's go ahead and find g of f. We got that. So now g is my outside function. So the outside function would be 8 over 7 times input plus 2. And once again, we just simply evaluate with x. So we plug in this is 2x minus 5. I prefer to do the extra step before I simplify. This is 7 over 1, multiply the numerators. So let me just continue here on the side. That would be 8 over 7x over 2x minus 5 plus 2. And now we proceed to multiply by the least common denominator to simplify my complex fractions. I multiply the 8 with 2x minus 5 this term with 2x minus 5, this term with 2x minus 5. It's the same technique that we did before. Now I'm just writing it in every single term. And now what do we have? Let's see if we can squeeze it here. 8 times 2x, 16x minus 40. These two cancels, that will be 7x. And here 2 times 2, that will be plus 4x minus 10. Which is what? 16x minus 40, 7 minus 7 plus 4, 11x minus 10. So that should be your final answer. Hopefully we don't make any boo-boos with sign. So now we just simply have to find the domain. What number I must avoid here? I add 5 divided by 2, so 5/2. What number I need to avoid here? I add 10 divided by 11, 10 over 11. And so the domain would be for real numbers except 10 over 11 and 5/2. And we're done. Hopefully you got that as an answer. Let's try one more example. If I have f of x equals 5 over 2x minus 3, g of x equals 7x minus 9. Let's go ahead and find the f of g of x, the fog, and its domain. Outside function 5 over 2 times x minus 3. In this case, the actual composition will be 7x minus 9. Okay. Notice that I do not have a complex fraction. I just simply have 5 over 2 times 7, 14x, 2 times negative 9, that will be negative 18, minus 3, negative 21. And we are done. What about the domain? Okay, so the domain, it will be all real numbers except restriction from the inside function. In this case, is 7x minus 9. Notice that 7x minus 9 is a linear function. This is not 1 over 7x minus 9. So I don't have to worry about any number here. The domain here is all real numbers. Therefore, I don't have any restrictions. This function 7x minus 9 is not limiting me to any number. However, the final answer has one restriction. Notice that I cannot input, if this is equal to 0, 21 over 14, which is of course divided by 7, that will be 3/2. The x cannot be 3/2. When this is equal to 0, we add 21. 21 divided by 14 is 3/2. And we are done. Only one restriction, because my inside function does not impose any restriction to the domain. Okay, I'll leave it up to you to find the g of f. Okay, I strongly recommend that you check out the document 3.4 composition of functions. Notice it has a very nice description of what it is, the composition function. How do we combine function? First, they talk about the sum, difference, multiplication, and quotient. It's a very nice example here, as we discussed in class. And then, of course, we talk about the composition. So f composed with g of f, composition g, f of g of x. Notice that one input becomes the output, where the output of one is the input of the other. Okay, so you have a very nice example here, and the definition, some interpretation, etc. Which one is inside, which one is outside function. So I strongly recommend that you read this information, and we'll go from there. Now, sometimes we need to evaluate the function using tables. So let's look at this table. X, this is the input, 1, 2, 3, 4. Of course, the output in f, the output in g. If they ask us to evaluate f of g of 3, what does it mean? First, we need to take 3 first, sorry about that. First, we need to take, we have f of g of 3. So we identify 3 in on the table, right? In the x, we look at the 3. This is the value f, and this is the value of g. So when the input is 3, the output using g of 3 will be 2. So now this guy becomes 2. So now we need to look for f of 2. So now we look for when the input is 2, what is the output in f? The output in f, of course, will be 8. I hope you saw the the doodling that I did on the right. I believe you can swap the screens if you want to. So anyway, so you have several examples here in this document. You can check it out. You can also use the graph. I'm not going to the graph. And right here, evaluating using the functions. Okay, so let's try this one. We have given f of t equals t squared minus t, and h of x equals 3x plus 2. We need to find h of f of 2. So what do I have here? When the input 2 goes into f, so I need to evaluate f when t equals 2. So we have 2 times 2, that's 4. 2 squared minus 2, that will be 2. So we're looking for h of 2. Once again, the 2 goes into the h, so 3 times 2, that's 6 plus 2, 8. They ask us to find h of f of -2. Now, -2 goes inside f. So when x equals -2, -2 squared, that will be -2 plus -2, that will be 4. 4 minus -2, that will be 4 plus 2, which is 6. So now we're looking for h of 6. And now this output goes inside h. So now we evaluate h when x equals 6. 3 times 6, that's 18 plus 2, 20. Okay. Okay, the domain, of course, we took out the domain. Anyway, I prefer the way I describe it. Of course, the domain, instead of doing all of these, always look at the restriction using the inside function and then using the outside function. I mean, the resulting function. That will be it. So you have several examples to attempt, and then I included the answers. I should just go in here. I included the answers, the odd answers right here. Okay, section 3.4, starting with 1, and the next page, you have up to get to 97. Hope this helps. Enjoy.